Hello everyone. Today today I am going to solve problems on unit and dimension chapter. This is referred to as H C VERMA book, and this is the first chapter of the H C VERMA, and we will solve numericals based on unit and dimension from this book. Okay. The first question is that find the dimension of linear momentum, frequency and pressure. Okay. So the formula we know that is means linear momentum, that we know that is P equals m into v. M is the mass and v is the velocity, and the dimension of m is mass and that of velocity is lt minus 1. So I can write the dimension of linear momentum is m l t minus 1, and means second one is that write the dimension of the frequency having a dimension of means time inverse. Okay, means 1 by t, or you can write the dimension of frequency is 1 by t or time inverse. And that of pressure we know that we say pressure is force per unit area, and the dimension of force is ml t minus 2 upon area l square. So I can write it ml minus 1 t minus 2. So this was the first question. Second question is write the dimension of angular speed, angular acceleration and torque. Okay, so what is saying that this is question number 2. Question number 2 is what? Angular speed. The angular speed, since we know the formula, that is v equals omega into r, and omega equals v by r, and the dimension of v is lt minus 1 upon l. So it can be written as lt means t minus 1. That is angular speed. And what is the next question is angular acceleration. Angular acceleration, so we are denoting it by alpha. So the formula of angular acceleration is alpha equals omega t minus omega 1 upon t2 minus t1. Okay, since what omega t and omega 1 is is attached by sign of minus, so both having a dimension of same dimension. Okay, similarly t2 and t1 is attached by a sign of minus signature, so also both having a same dimension. When a quantity is attached, or is combined with a plus or minus signature, then both quantities would have a same characteristic, or same dimension. Okay, so similarly here omega t and omega 1 having same dimension, that is of what right now we have calculated, that is t minus 1, and that of this is t2 minus t1, this is time, so this also having dimension of t, so we can write it t minus 2. Okay, and third question is write the dimension of torque. Okay, the formula of torque is denoting it by torque. The formula of torque is what? Force into displacement. Force into displacement, or is a distance. So this is ml t minus 2 into l. So it can be written as m l square t minus 2. This will be the dimension of torque. And the last one is that means calculate the dimension of moment of inertia. Okay, so moment of inertia is getting denoted by I, and the formula of moment of inertia is mr square, and m is what? Mass having a dimension of m, and r is what? Distance, so having a dimension of l square. So this will be the dimension of moment of inertia. Okay, this was the second question. Now next question is what? Find the dimension of electric field, magnetic field and magnetic permeability coefficient. Magnetic permeability. Okay, so this is question number 3. Okay, so what is we have to find out the dimension of electric field. Electric field, since we know the formula, means we know that is F equals Q, F equals Q into E, and E is electric field, F is the force, and Q is the coulomb. Coulomb means what? It is the charge. It is the charge transported by a constant current of 1 ampere in 1 second. Okay, of 1 ampere in 1 second. Okay, and you know the dimension of force is ml t minus 2. So from here we can calculate E will be F upon Q. So the dimension of F is what? ml t minus 2, and that of Q is ampere into time. So we can write it ml t minus 2 minus 1 minus 3, and this is a minus 1. Okay, and the second means B, it is saying that find out the dimension of magnetic field. So magnetic field, so it means the formula of magnetic field, F equals Q V B. F is the force, Q is the coulomb, Q is the charge, and having means unit is coulomb, and V is the velocity, B is the magnetic field. So we have to calculate, we have to find out B. So B will be F upon QV. Okay, so F, the dimension of F is mlt minus 2, and that of Q is ampere into time. Already we have calculated here, and velocity will be lt minus 1. So it can be written as m, ll get cancelled, so t minus 2, and that a minus 1. Okay, so this is for magnetic field. Now third is what? You have to calculate magnetic permeability law. Magnetic permeability. Magnetic permeability. Okay, denoted by mu naught. So the formula of magnetic permeability is B equals mu naught I upon, that is 2 pi A. So B is the magnetic field, I is the current, electric current, A is the distance, and mu naught you have to calculate. So we will calculate mu naught as what? B into 2 pi A upon I, and the dimension of B already we have calculated here. This is m t minus 2 a minus 1, and the A is what? Distance. So distance is L, and current A. So the dimension will be of mu naught m L t minus 2 a minus 2. Okay, so we have calculated the dimensions of electric field, magnetic field, and magnetic permeability. Electric field is F equals Q into E. Q is the electric charge, and E is the electric field, and F is the force. Okay, so in this way we have means by doing the cross multiplication, and just writing the dimension of each individual term, we can calculate the dimension of E. And for magnetic field, F equals Q V B. Q is the electric charge, having means unit is coulomb, and you say it is getting defined as it is the charge transported by a constant current of 1 ampere in 1 second. Okay, 1 ampere in 1 second. V is the velocity, V is the magnetic field. Okay, so B equals F upon QV. So dimension of F is mlt minus 2, and that of Q into V. Q is A into T, and that of V is lt minus 1. So in this way we have calculated mt minus 2 a minus 1. And similarly for magnetic permeability, we just by writing the formula and doing cross multiplication, substituting each term's dimension, and we calculated the dimension of this magnetic permeability. Okay, so the next question is and so this is question number 4. Okay, so means what? This is for electric dipole moment. Electric since electric dipole moment, it is what P equals Q into D. Okay, so you have to calculate the means what dimension of electric dipole moment. This will be what Q already know 80 and that of D L. So this can be L 80. Okay. Next question is what magnetic dipole moment. Okay, magnetic dipole moment. So the formula of magnetic dipole moment, this is I into A. I is the electric current, A is area. So means the dimension of I is ampere and that of area L square. So we can say the dimension of M is what magnetic dipole moment. This is L square A. A stands for ampere. Okay, and next question is that calculate the dimension of Planck's constant. Okay, since we know the formula A is equal to H into nu, and from here the dimension of H can be written as E upon nu. The dimension of A is what ml square T minus 2. E having the same dimension as that of the work, and work force into distance, so we can calculate from here that force means ml T minus 2 and distance getting multiplied by L. So the dimension of E will be ml square T minus 2 and that of nu. The nu is having a dimension of T minus 1. Nu is what frequency. So the dimension is written here, that is ml square T minus 2 and plus 1. So this will be this much. Okay, so this is the dimension of Planck's constant. Okay, this was the fourth question. Now it is saying that calculate the dimension of gas constant. Okay, gas constant. Gas constant I to found ideal gas law, that is PV equals nRT. So from here we know that is R equals pressure volume upon and into time. The pressure is what force per unit area, and this is volume, and is what moles, and this is time. This is temperature having a unit of Kelvin. Okay, so force ml T minus 2 upon L square into L cube upon mole into Kelvin essay. So I can write the dimension will be m L square L cube. So L4 upon L2 okay. This is the dimension of gas constant just by means writing the formula PV equals nRT and doing mathematical operations and writing the dimension of each individual terms, force, area, volume, mole and Kelvin. We got dimension of gas constant. Okay. Next question is write the dimension of this specific heat capacitance. Specific heat capacitance. So since we know that is Q equals M Cp delta T, and this is the specific heat capacitance. So we write it Cp equals Q upon M into delta T, and Q is the amount of heat. So having a dimension of joule and having a unit of joule, and M is mass and delta T is temperature. Temperature means we will write the dimension Kelvin. So joule having same dimension as that of the energy. Energy having a dimension of M L square T minus 2 upon M and K. So this will be L square T minus 2 into K. Okay. So this was the specific heat capacitance. Next one is coefficient of linear expansion. Okay, coefficient of linear expansion, since this is written as LT equals L naught into 1 plus alpha T2 minus T1. Okay, so L naught is what? L naught is the LT represents the length at time t, so dimension equals L, and this is also L, so both will get cancelled. So the dimension of alpha is what? Coefficient of linear expansion, alpha having a dimension of 1 by delta t, so this can be written as t minus 1, or I can write it, this is having a dimension of alpha like this, okay? Alpha t minus 1. Now next question is, it is saying question 6, 7 is very easy, you can also solve it by your own. And question number 8, it is saying that means you have given acceleration due to gravity is what? This is what? 10 meter per second square. Okay, so it is saying, in the question it is saying that convert it in terms of centimeter and this in terms of what? Minute. Okay, and then means what will be the value of g then. Okay, so what we will do, same means g will be 10 into 100 centimeter equals 1 meter. Okay, so 100 into centimeter upon, and this is what? 160 second equals 1 minute, so I can write it 60, this is what? Second, this is minute, sorry, we are converting into 1 minute, so this will be since this is power of 2, so this will be 3600 into 10 into 100 centimeter upon second square, so this I can write it. Okay, this is question number 8. And question number 9, it is saying that means speed is given as 70 miles per hour. In question it is saying convert miles in meter and converts hours in what? Second. Okay, so what we will do, first of all we should have to know that 1 mile equals what? 1609.344 meter, and 1 hour equals 3600 second. So speed will be 70 into upon 36. Okay, unit will be meter per second. So just after doing calculation, we will get the value will be what? 31.2928 meter per second. Okay, so this was question number 9, and the last question for this class is, let me write. So in the last question it is saying that the height of a mercury column in a barometer in a Kolkata laboratory was recorded to be 75 centimeter. Calculate this pressure in SI and CGS units using the data. Specific gravity equals 13.6, density of water 1000 kg per meter square, and acceleration due to gravity is 9.8 meter per second square. Okay, what is saying that suppose this is a barometer. Okay, this is what? This is a barometer. Okay, so it is saying that it is saying that is what? The height of a barometer indicates in Kolkata laboratory, that is 75 centimeter. So, and the given data is what? This acceleration due to gravity, it is given at 9.8 meter per second, this is given. And another thing, specific gravity is given as what? Specific gravity 13.6. Density of water, it is given, that is 1000 kg per meter cube. So first of all we have to calculate, means what? Density of mercury, means density of mercury. So how we will calculate? So since we know, since to be specific gravity equals density of mercury upon density of water, so means what? 13.6 equals upon 1000. So I can write, means density of mercury equals kg per meter cube, and we have to calculate pressure. Pressure will be rho GH. So this will be 10600 into 9.8 into 75 into 10 raised to minus 2. So this will be what? 99960. Okay, this is kg per meter second square. So okay, so this will be 99960 Newton per meter square. Okay, okay. So I am stopping here, and means I will continue more problems on unit and dimension.